Okay, here we go. So these are the notes that teach us how to we want to be able to graph exponential functions. And so the first one we're going to look at is where the base is 2, and notice the x is the exponent here. So this is y is equal to 2 to the x. So I'm going to start off by first I want to fill in my table. Alright, so negative 1, so 2 to the negative 1, that's going to be 1/2. And then if you'll remember 2 to the 0, so when x is 0, that's going to give me 1. And then 2 to the first, when x is 1, that'll give me 2. And then 2 squared, that's going to give me 4. And then 2 cubed, when x is 3, that's going to give me 8. And so I can keep filling this table in. 16, 2 to the 5th, so x is 5, that gives me 32. And then when x is 6, that gives me 64. Okay? So now whenever we graph the parent or graph transformations, we're only going to focus on these points right here, negative 1, 0, 1, 2, and 3. Okay, so we'll focus on these x's right here whenever we graph. Alright, so let's take a look at what the parent looks like. So notice it starts, we'll call this the vertex or our starting point, 0, 1. So I'll put my dot there. And then I'm going to go negative 1 and 1/2 right here. Put a dot. And then I'm going to plot these other points. So 1 over 2, 1 up 2, go over 2 up 4. And then when x is 3, y is 8. Okay. And so my graph is going to look, if you plug this into your Desmos, is going to look something like this. And so this is my parent function. Y is equal to 2 to the x. So now my domain clearly is going to be negative infinity to infinity, because notice it goes all the way out here to negative infinity, then it's going all the way up here, it's getting wider and wider and wider, so it's going to cover all my x's. And then the range is going to be, now look at this, y greater than 0. The reason it's y greater than 0, it never touches the x-axis. So remember the x-axis is where y is equal to 0. My graph is never going to touch the x-axis. So that's why my range is going to be y greater than 0. Now my x-axis for this graph, this is called a horizontal asymptote. Horizontal asymptote. And so my equation for that is going to be y equals 0. And so what is different about this parent function than the rest? Well, we have a 2, we have a base of 2. We could also study where it's a base of 3, base of 4, and so forth. But our exponent is the x. Alright, so now let's go ahead and make sure we know how to graph these. Alright. So let's focus on number 1 here. Whoops. So let's focus on number 1. So to start off, I want to make a table. Alright, so I want to make a table over here. So I'm going to go x, y. And we're going to go negative 1, 0, 1, 2, and 3. Just like that. Now when x is negative 1, okay, that's going to make this 0. So 2 to the 0 power is 1 minus 3. That'll give me negative 2. Okay. And so now when x is 0, well then 0 plus 1 is 1. So that'll be 2 to the first, which is 2, and then 2 minus 3, that'll give me negative 1. Now if you have to, you can use your calculator to figure that out. And so now when x is 1, so that's going to be When x is 1, that'll be 2 to the 1 plus 1 minus 2. So 2 squared is 4, minus 3. So 4 minus 3, that gives me 1. And this is a 3, by the way. So 4 minus 3 gives me 1. So I'll put 1 right here. And then when x is 2, that's going to be 2 to the 2 plus 1 minus 3. So that'll be 2 cubed is 8 minus 3. That'll give me 5. Just like that. And then when x is 3, that'll be 4. So 3 is not going to fit, so we don't have to worry about that. So now we're just going to plot these actual points. So I'm going to go -1, -2, put my dot. Then I'm going to go 0, -1, put my dot. Then I'm going to go over 1, up 1, put my dot. And then over to 2 from the origin, go to 2, and then go up to 5 and put my dot. Now look at this right here. -3. So we have a -3 right here, okay? So since our k, so to speak, outside, it's a big number, -3, that means our asymptote is going to be at y equals -3. So this is going to be my asymptote right here. So I'll just draw it like that, okay? And so that's going to be y equals -3. Alright, so my asymptote will be at y equals -3, and then I'm just going to sketch my line like this, and it goes up like this, and so there you go, there's your graph. So notice your transformation, we got plus, okay, we got plus here with the x, so that's going to be shift left 1, and then the -3 out here, that's going to be shifts down 3, shifts down 3. So notice right here, okay, if we go back and look at the parent, notice we got 0, 1 right here, and so with this, we shifted this point right here, the starting point, 0, 1, we shifted it left and then down 3 to -2. And so that's how we got this point right here. Okay, so we start right here, we shift it left 1 and then down 3. So 1, 2, 3. And so this is the starting point after it's shifted. Alright, and so now the domain is going to be from -infinity to infinity, and then the range is going to be y greater than our asymptote, so that'll be y greater than -3. I don't know why those are there. Oh, I guess set notation. X is in the set of all reals, and then range will be range is going to be from in set notation, or like this, -3 to infinity. Actually, I got these reversed. This is set. Okay, and then notice my line as x gets bigger. Notice my line as x gets bigger, it's going up like that, so this is going to be increasing.